Okay, welcome back. What I want to look at today is graphs and equations of lines, okay? And how those are come about. Now the objectives here, the students will be able to draw a straight line, find the equation of a straight line. Starter, I've used starter here. I have the following input to a money machine. Every pound I put in, I get £3 out, okay? So imagine that for a moment. Brilliant, won't it? So I'm putting in 3, I have minus 2, so 3 times minus 2 would be minus 6, so that will go there. Minus 1, 3 times minus 1 would be minus 3. 3 times 0 would be 0. 3 times 1 would be 3, etc. 3 times 2 would be 6. So you could see my output machine would be giving me a value of more than 3 times as to what I put in. Okay, main task. Use my maths coordinates, then coordinates 1 and 2. Okay, some of you have used my maths book at schools because this is taken from that as such. And when I was teaching maths at school, then this is something that I would use myself. Okay. Let me just make sure we can get this in and read it is clear to read. One way of drawing the graph of an equation is to obtain a set of coordinates from the equations by means of a flow diagram. These coordinates are then plotted and the graph is drawn. Now remember that the graphs drawn here are not precise, okay? They ought to be, but there are some errors in printing, so forth, okay? So I will try to highlight those as I go on. Okay, let's just get this in, okay? Let's see if we can get this up. Okay. Right, in its simplest form, a flow diagram consists of a single box which may be thought of as containing a mathematical operation called a function. A set of numbers fed into one side of the box is changed by the operation into another set which comes out from the opposite side of the box. For example, the box shown here represents the operation of multiplying by 3. Okay. Okay. Come back, make sure we got it in frame. And this is my box. As I said before, as shown before, okay, and that came from here. Okay, so let's not forget where that came from. That came from this box ID here. So all I've done now is to apply that principle to here. Okay. And we have now 3 times minus 2, minus 6. 3 times minus 1, minus 3. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. Okay. That's simply not to follow. Okay. Now, flow diagrams are sometimes called function diagrams. The numbers that are fed into a box are called input values, and the numbers that come out are called output values. Okay. We can match the input and output values and arrange them as a table. Just make sure you have that in view. Okay. Now write these things out for yourself so you understand the concepts behind it. Write them out. Don't just try to do them on the screen. It does not work. You have to apply this so your brain registers the process and the function involved. Okay. And here we have our table. Minus 2 minus 1, 0, 1, 2. Minus 6, y equals minus 6, minus 3, 0, 3, and 6. The input values are called the x values, and the output values is called the y values. Okay. Now let me just move in a little bit so we can get that. You can make this particular diagram draw the axis, x-axis, horizontal axis from 10 to 10. Sorry, my apologies, from minus 10 to 10, and the y-axis, vertical axis from -10 to 10. You can use any type of graph or square paper to draw your axis, but do note that the scale on each axis is not just always the same. Okay, and that's what your axis with your scale frame should look like. Now please note, this is not to scale, this is purely for illustration. Now, example, for each of these flow diagrams, work out the missing numbers, complete the table of values, write down the equation that each set of coordinates pairs represents, use the coordinates from each table to plot points on the graph, and hence draw the graph of the line given by each equation. Now please note, some of these graphs are not precise, okay? There are slight errors in them, but I'll try and highlight those as I go on, okay? And here we have A. Right? Now, what I've done is just to, you'll notice that here it's giving you 4 times function, then a minus function here. And we need to know what y values are. So what I've done here is just simply to do this by hand, okay? And I'm going to bring it into view now, okay? I'll bring what that, so you can see that here, that value is now, okay? And I'm hoping that I can get this right, okay? That it will allow me to show you this, okay? Okay, now you can see that there I've got -8, -4, 0, 4, 8, and at the end it's -9, -5, which is the value that we would want for y, okay? Right? And I'm just doing that just as to assist you in how we arrive at these values, okay? Let's take that away now, okay? And we got B. Again, here, similar thing you will need to be doing. So I want you to get familiar with this before I take you on to the solutions, okay? And here you have C, okay? Right, now let's have a look at the solution for A. And here we are, okay? -9, -5, okay, and so forth, etc. The equation is y equals 4 times x minus 1, graph is shown on the right. Now here, where x is equal to -2, x is equal to -2, y is equal to -9. And here you are, we have it here. -2 and x equals -9. And that point should be there actually, okay? So this is like, this graph is slightly off, okay? And then when x equals -1, y is equal to -5. So again, x equals -1, that one should be there, x should, that should be there. So graph is slightly off, okay? So in this case, allow for that variation, but you can see the idea of here of plotting the graph. So you'll just put these as dots. Here -5 there, that would be -9 there, etc. Then you got to note where x equals 0, then y equals -1. Where x equals 0, y equals -1. So I think they've made slight variation here, but you can see the idea. That would have been somewhere here, basically, okay? Okay, and then when x equals 1, so x equals 1, y would equal to 3, and that would come here, somewhere here, again, okay? So you can see that our graph is slightly out. It's not quite perfect, but that you get the idea of that overall, okay? Let me make sure I've got this in line, okay? Let's pan back a bit to make sure we get it in, okay? Okay. And for B, Here you can see that applying the same principle, the missing function in the first box is times 3, the times becomes, and that's what you then have, okay? So when x equals minus 2, y equals 1. So x equals minus 2, y equals 1, and that comes across, that would be there, okay? That would be correct, okay? And you can see that. Now here, I don't like the way they've done their graph. I normally would like my graph to go all the way down, but I can see why they've done that, to save space. So they just take it on the x-axis, okay? And again, when x is 0, y equals 7, and we're here, this one is smack on, okay? And then when x equals 1, y equals 10. So x equals 1, y equals 10. That is perfect. That is a perfect match. Excellent. Okay. Okay, now write these out for yourself. Use graph paper to draw your graphs. Okay. So that would be okay. And here we have additional information now. Go to my maths, algebra, then conversion graphs, then using GCSE Maths Foundation page 268 to 71, a Excel work for exercises. Now go to shape in my maths, then coordinates, etc. Now here, this is just a function. Turn to page 268, straight line graph. Do example 2 and draw the graph to scale. Now some of you may have this book actually, okay? So I'm going to leave it in. Then do example 3 on page 269 and do exercise 16 or 16b on page 270 to 272. Use real life graphs in my maths, okay? And real life graphs just meant that the data is taken from real events. Okay, goodness me. Okay, I hope you found this useful. Now this is year 11 mathematics, so get used to doing it. Write out the work, okay? Right, get it done. Okay, and I'm just going to move up on this slowly so we can get it all in, okay? I'm hoping that quality has been good on this, okay? So that it makes it clear, can be seen clearly. That's the idea, hopefully. Okay. Okay, excellent. Thank you. I hope you found this useful. Have a good day. Bye-bye.